Alright, this is part 3 of our study guide video. Here we go. This is another split the middle term. So we got to take the two numbers, the front and the back number, multiply those together. We get 2 and 6 makes 12, and then 7. The two numbers that are going to make this will be 3 and 4. We're going to split that middle term into 4x plus 3x. Bring down the 6 and bring down the 2x squared. Okay? Now that we split that middle term, 7x has become 4x and 3x, we can go ahead and factor by grouping. We take out the GCF here of 2x. We get x plus 2. And here we're going to take the GCF of 3 out and get x plus 2. They look at the same. And then we're going to get 2x plus 3 and x plus 2. Okay? All right. Next one, x factor, 6 times 25. Now this is going to get to be pretty large numbers here. If you think about having 6 quarters though, we know that's 150, so that's 6 times 25. And we get negative 25 down here. You got to think of multiples that might do this, yeah? Negative 10 and negative 15, nice job. And we're going to go ahead and break that down. We get negative 15x plus, sorry, not plus, minus 10x. No. Plus 25. And 6x squared. Okay? Factor by grouping. The first one I can pull out a positive 3x. To leave me with x minus 5. Back here I can pull out a negative 5 to leave me, sorry, this is 2x minus 5. Give me a 2x minus 5. They look at the same. We get 3x minus 5 every time. And 2x minus 5. Okay. Again, these problems are lengthy, but they follow the same traditional pattern, right? We're going to multiply the first and the back number together. And then go ahead and do our normal x factor to split the middle term, and then we factor by grouping. Okay? So you can always go back and catch the rest of this in the video. I'll just wait. I hope I had more lead. Oh gosh, I'm going to be so sad. No! Okay. Oh no. Okay, pencil. Good. 38. Alright, we're at dots. This is difference of perfect squares. They're both perfect squares, so we're just going to go ahead and get x minus 7 and x plus 7. It's that easy. Okay? You just take the square root of both, and you put them in between a plus and a negative. Number 39 is also dots. We take 2x minus 6, and then 2x plus 6. Notice I'm just taking the square root of each, and then you're doing minus and plus between them. Okay? Alright, and roll it down, 40. I got a couple more, we're good. It looks like I can pull an x out, and, oh, wait a second, Mr. Smith. This looks like factor by grouping. Silly me. Right here I could take out a 4x squared, that gives me x minus 4. Over here, it looks like I can take out a negative 3, which gives me x minus 4. They look at the same. They look at the same. Not ready for that one. And there we go. Yeah, sorry, that factor by grouping came out of nowhere. And looks like 41 is also another factor by grouping, so we better have our laugh ready this time.
Yeah, right.
15x to the third and 6x squared. I can pull out an x squared and looks like probably, most likely a 3. That's going to give me 5x minus 2. And back here I can take out a negative 5. That's going to give me 5x minus 2. They look at the same. There it is. And I know I'm going kind of quickly through these. And again, it is your mission It is 12 o'clock. It is your mission to make sure that you guys have these down. Okay? You want to make sure that this is ready to go. Okay? 42. Fill in the missing factor. That sounds pretty exciting. For this one, we're going to basically, I think it's easiest just to X factor here. You got 14, you got 9, but it's already telling you that one of the numbers is 2. Well, what times 2 gives you 14? 7. So that makes this really easy, right? Next one, fill in the missing factor. It's, again, a very simple one, where we're going to take 24, negative 10, and it's already telling me one of them is negative 4. So it's got to be a negative 6. It has to be a negative because 2 negatives make a positive. And there we go, 43. In the books. Okay. Ooh. Here we go. Fill in the formula to help you solve the following problems. Yeah. Axis of symmetry. You know what would be great for a note card? This stuff. Okay? Yeah. B over 2a. Axis of symmetry, negative b over 2a. I'm sorry. Quadratic. Alright, x equals negative boy, couldn't decide, go to the radical party, didn't want a b squared, miss out on 4 awesome churros. You didn't want the whole thing to be over at 2 a.m. Or just 2a. The discriminant is just the part under the square root. B squared minus 4 awesome churros. I got a churro when I went to Disneyland. It was delightful. Yeah. I actually have a selfie with. I gotta get that to you. I'll loop it to you.
I'll loop it to you. Oh my god.
That's loop mail. Is that how kids talk nowadays? They loop things to each other?
I mean, last time I heard some kid ask about some girl. What?
Done. Alright, we're talking during the middle of my video. Describe what a zero is, both graphically and algebraically. Here we go. Boom, boom. There's a parabola. Boom, 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 boom. These guys right here, those are zeros. It's when my when my graph hits the x-axis. Okay? Algebraically, so that's graphically. Algebraically, it's when we have y equals 0, okay? When y equals 0, that's when we have my zeros, okay? Notice the y goes to 0, that's how I get x equals 0. So it could be anything like that. What are all other names for zeros? Intercepts, specifically the x-intercepts, okay? Anyone have another one? Okay, roots is another one. That's a really good one. Okay, a lot of times we just say what x equals, it's solving for x in a lot of these problems. But those would probably be, I would say, the two main ones. All right, 47. Fill in the blank below. If the discriminant is positive, the quadratic will have how many solutions? Well, think about it. If you took a square root of a positive number, any positive number, you're going to get 2 solutions, right? Put it in a calculator. If the discriminant is negative, if you get a negative number, can we take a square root of a negative number? No, so you get no solutions. And if it's 0, what's the square root of 0? It's just 0, so you only get what? 1 solution. Okay? Awesome. Awesome. Alright, tell whether the graph of the quadratic is up or down. Ding, 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 ding. Ding, 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 ding. What's that mean? Down. Okay. So negative is down. Positive is up. This is the A value. Okay, A value. Going back to the old school A value. Okay. 49, identify the vertex and the roots of the parabola. Determine if it's a min or a max. So my vertex is right where it changes direction. That's going to be at 4, negative 4. My roots, boom, right here and here. So my roots are going to be at 2, 0, and 6, 0. That's 1205. Thank you. Alright, those are my roots. Min or maximum. Is this graph going to ever have a max? No, it's going up forever. Will it ever have a minimum? Yeah, it's the vertex right here. So there it is. It's a minimum. Much like we're going to have a minimum day schedule here coming up. Okay. Last problem. Boom. 50. Identify the domain and range of the quadratic below. Okay, so I'm going from here all the way down to infinity on my y-axis, and my x-axis is going to infinity in both directions, isn't it? As it goes down, it's slowly going outward forever. Name that movie. Sandlot, good job. Forever. Excellent. Domain, if you guys recall, the domain is my x values. Remember I say, this is my domain, my x values. Okay? So the x values is going to be all real numbers. You can't see that. So I'm going to zoom out. Yeah. Okay. The y is going to be the range. Remember? Shooting down the range. Okay. The range is going to be any number, right, up to 4 or less, right? So y is going to be any number that is equal to or less than 4. Okay? Equal to or less than 4. And there it is. Part 3. We have finished. We're going to finish part 4. Probably might take 2 parts to do the other part. I just said part a lot. All right, part T.